Hello and welcome back to another LeetCode problem. Today we're going to be doing problem continuous subarray sum. And it's definitely an interesting problem and it's quite tricky to solve. So we're going to go over it. So given an integer array nums and an integer k, return true if nums has a good subarray or false otherwise. A good subarray is a subarray where its length is at least 2 and the sum of the elements in the subarray is a multiple of k. Note that a subarray is a contiguous part of the array, and an integer is a multiple of k. There exists an integer n such that x equals n times k. 0 is always a multiple of k. Okay, so let's take a look here. So our first example is 23, 2, 4, 6, 7. And so we are just trying to find, is there a subarray in here that's at length at least 2 and is a multiple of k? Yes, there is. This one right here. So k is 6. This one would not work. Okay, and I think you can have negative numbers here. Let's see here. No, you cannot. Okay, that's fine. Okay, so now we have, so for this one, there definitely is a subarray. Now let's go to the next one. 23, 2, 6, 4, 7. And there is one as well here, actually, that is a multiple of k, and I think there are a couple. So, like, this would be a subarray. And then this whole thing is a subarray because that's 42, which is also multiple of k, so there are 2 subarrays there. Okay, and then for this third one, so you want a multiple of 13, so this is like, yeah, so there's nothing here. That's continuous anyway. But let's just go through this one. Let's say we try to do this. Like, what would be the brute force of doing this? Well, it would be pretty straightforward. We would have to get the subarray starting at every index, and then we'd have to get every single possible subarray. So, like, for example, let's start here. We would have to get all subarrays starting from this index that are length 2 or more. So, right, so like this subarray, this subarray, this subarray, and this subarray, right? Or just 23 and 2, 23, 2, 6, 26, 23, 2, 6, 4, 23, 2, 6, 7. And so then you would have to do all subarrays start from this index that are 2 more. So this subarray, and this subarray. And you can just divide them by 13 and check for remainder 0, right? Then you would do this subarray, and then finally this subarray. So what would be the time complexity for something like that? Well, it's going to be n squared, right? N squared, right? N by n. Because we are doing pretty much a nested for loop. Now let's actually take a look at the constraint. So the constraint is the num's length at 10 to the 5th. And so that's not going to work for that because 10 to the 5th squared would be like 10 to the 10th, and for LeetCode problems that's not going to work, so we need something more efficient. So we need to figure out a way of how do we actually figure out if a subarray, like, how do we have a more efficient way of figuring out a subarray? So let's think of what the question's actually asking, right? So it's saying, is it an integer n that's a multiple of k? So what does a multiple of k mean? Right, so if you have some n that's a multiple of k, what does that mean? That means that k times x, right, equals n. So there's some integer x here that k equals n. Also, what another thing it means is this. N mod k is 0, right? And that's what we can use. The other thing we're going to be able to use is that we have contiguous subarrays. So that's also going to be important. So let's think about a few cases here, right? So let's say we have some integer, and we're gonna look at these examples with, I think, what were the so 6. Let's look at 6 in both of these, for example. So let's say we do have some integer that is a multiple of k, right? So we have some k times x equals n. Okay, and so we have some number, like let's say we have an array that's like, you know, the elements add up to 6 here, and then you have some other stuff. And then you get some other elements that add up to another multiple of 6, right? So those would be like the easy cases, right? Where if you get anything that adds up to 6 and then say something else that adds up to 18 or so on, then you would know that like this is a subarray as long as this is length 2, this whole thing is a subarray. So that would be like an easy solution. But let's think of other cases, and this is pretty much going to help you understand how mods work. So if n mod k is some number, like let's just say it's 1, right? So for example, what would be a number here that n mod k would be 1? Well, something like 7. So let's say we have 2 elements in this subarray that, so I'm actually going to delete this. And this is going to help us get some intuition here. So if n mod k equals 1, so let's say we have a subarray and we're trying to get, let's say we're trying to get even 7, right? We have a subarray, and then to get 7, we would need n to be like 8. So let's just say our numbers are like 2, 2, 4 so far. And so this, and so if k is 7 here, right? Then this mod k, like this whole sum mod k, would be 1, okay? Now, what happens if we get another? If we get something else in the future that the remainder of that whole thing is 1? Well, how would we do that? Well, what would be another number that's like that n mod k would be 1? Well, let's think about that, right? So let's say we have 22 total. So let's just say we have like some numbers and all this whole thing ends up to, this is 8. So let's just say we have like a 6, that's 14, and then we have another 8, right? And so this whole thing is 22 now. Okay, so the sum of this whole thing is 22. Now, when we take this subarray right here, so this n mod k equals 1 here, right? Because this would be 8 mod 7 equals 1. Now, if we do this whole array, this is 22. So now we do 22 mod k. So 22 mod 7 again equals 1. So what does that actually mean for us? So if we ever get the same remainder, like what does that mean for us, right? And so what it actually means is there has to be a subarray in here that if you get the same remainder, that means there has to be a subarray that if you actually subtract them, right? So if 22 mod 7 is 1 and 8 mod 7 is 1, that means if you actually subtract those two subarrays, so 22 minus 8, then you get 14. And so if you get two numbers that those two numbers mod 7 is 1, that means those two numbers subtracted from each other, mod 7 is going to be 0. And so if those two numbers mod 7 is 0, that means this 14 subarray is the good subarray that we want. So we could do that with other numbers just to give you some more intuition. So let's say we're trying to have like 5, and we have some subarray that adds up to like 7, let's say, and then we have some other subarray that adds up to like 27 or something, right? And so if you think about it, and so this is going to be like a prefix sum situation, right? Where like this whole thing adds up to 27 and this small chunk adds up to 7. That means this chunk in the middle has to add up to 20. And so once again, you would get the same thing where 20 mod 5 is 0, but 7 mod 5 is 2, and 27 mod 5 is 2. So that's really all we're going to be doing is we're going to be going through this array. We're going to be maintaining a total and the remainder, and we're going to say if we've seen this remainder before, that means there is some chunk between where we are now and where we've seen the remainder before, where that chunk is a subarray that when you mod it by the number we care about is 0. And so hopefully it makes sense. Yeah, so I'll show you for this example 5. Like let's say we have this 7, right? So we have like a 2, or let's say we have 3, we have a 4, and then we need this part to add up to 20, right? So we can do that. So we can do like 13, 7, right? And so we're gonna go over here. We're gonna say, okay, well we have a remainder 2, and we're gonna save these remainders in a hash map, and then later on we're gonna look up like, did we see this before? So when we get to this part, then we're going to see that this is like remainder 2, right? So we're going to say, okay, we have a total sum of 7. So it's actually I'm going to show you like how this will work in some other examples, actually doing like a dry run of it. But for now, so let's just say this is remainder. So this is 7 mod 2. So that's going to be, or it's actually mod, but yeah. So 7 mod 2 is going to be 2. We're going to say, okay, we've seen this 2. Now, when we get to this whole sum, we're going to say, okay, this is 27 mod 2. Have we seen that before? Or, sorry, it's not going to be 27 mod 2. It's going to be 27 mod 5. Yeah. Okay, because we're looking for 5. So 27 mod 5 is 2. Have we seen it before? Yes, we have. That means that this whole thing minus some previous thing is our subarray. So this whole thing minus this chunk is the subarray we want. And now I don't think that they care about like giving the subarray, but we can just know that there is one. So let's actually do a dry run of this algorithm for, let's just say we do it for this problem right here, for this example. We can do it for both, right? We can do it for both of these examples. Okay, so let's do that. So we have 23 to help you understand it better, because I do think I could have explained it a little bit better, but once we do like a dry run, you're going to be able to see what's going on. Okay, so our k is 6. And what we're going to do initially, there's a couple things we need to do to make it work. So for one thing, they are looking for arrays with length 2. And so if you just had something that started with a 6, like let's say your array was like 6, 4, or even like 6, 6. I think 6, 6 would work, but if you had something like this, you can have something like this. You want to make sure this works as well. And so the way we're going to make sure arrays like this work is, what we're actually going to do is we're going to have a starting index. So let's say this is our hash map of our remainders. We're actually going to set the things with remainder 0 to have an index of -1. Therefore, if we just have an array like this shouldn't return true because we need elements of size 2. But if we get something like this, or actually if we get something like 0, 6, I think 6, 0 should also work, then it would work. So we're going to compare the index of the last thing we saw to the current index, and as long as they are, more than one apart, that means we have valid subarray of length 2. So this is going to be like our base case where, if you have some whole array be a multiple of 6, we just have to make sure, is that array 2 elements or more? And if we are at this index, that would work, right? Because this is index 1, so then you would do 1 minus -1, and that would be 2 indices away. But if it's just this first index, then it wouldn't work. So if this first index does satisfy it, then that would only be a difference of 1. Okay, so let's do the dry run now. So first and remember we're getting all these remainders, right? So first we look at this, and then what's that 2 mod 6? So it's pretty straightforward, right? So 2 mod 6 is going to be 0, remainder 2, right? So we're going to have a 2, and then remember we're going to store the index where that is. So this is index 0. I'll just write the indices up here real quick. 2, 3, 4, 5. Okay, now we keep adding. So we have a cumulative total. So now we have 5 mod 6. What's that? Well, that's just 5. So we have 5 at remainder 1. And every single time we get a remainder, we're going to say, did we see it before? So far, we don't have any duplicates, so we haven't. Okay, now we are over here. We're going to add again. So 5 plus 4. So it's going to be 5 plus 4, 9, mod 6. So many emails. Okay, and that's going to be 3. Okay, so now we have 3, and we have it at index, let's see here. So we have it at index, so I think, yeah, that should be fine, that should be fine. This 2 should be at, let's see here. Oh, okay, so I made a small mistake, so this should be not 5 plus 4. So we forgot to add this 2, so let's do that. So this should be 7 mod 6 equals 1. And so let's just add a 1 in here. That's going to be at index 2. Now we add the 4. So now we get 11 mod 6. We get 5. And so now we did get a duplicate. So we got a 5, and then we just ask what index are we at and what index was the last 5 we saw. So we're currently at index 3. The last one we saw is at index 1. Are those 2 more than 1 index apart? Yes, they are. That means like after we got to this point, we have a subarray, and we do have a subarray, right? It's right here, this 2, 4. Okay, so let's do another one for this second example, and we can do one for 13 as well, and then we'll be done. We can just code it up. The code is pretty fast. So 23, 2, 6, 4, 7. We are looking for 6. And so our result is going to be, once again, it's going to be 0, -1 here. Okay, so we have a 2 mod 6. It's going to be 2. So that's going to be 2 at index 0. Okay, we haven't seen that yet. So now we go over here. 5 mod 6. 5 at index 1. You can speed this up a bit. 7 mod 6 equals 1. 1 at index 2. Then we add a 6. 13 mod 6 equals 1 at index 3. So we have seen it, but so this is the other case that we need to run into. So yes, this is like we have seen it, but you can see that these are only one index apart, so that's not going to work. And then what we want to do is if we do have the same if we have the same like value, what we want to do is keep the old one. So we're actually not even going to use this one. We want to keep the old one because we want to make sure that we can have an index length of 2 or greater, and so keeping the old one is more beneficial for us. Okay, so now we're going to add this. So this is going to be 17 mod 6 equals 5, and now we have seen a 5, so this is at index like 4, and we have seen a 5 at index 1. So now we know that we have a valid solution, and let's just make sure. And yeah, right when we get to this 4, this is a valid solution. But before this 4 was not a valid solution. So it's the same thing. And then if you did this for 13, you would never get matching indices. So we're not going to actually do that one, but you kind of get the point. So our algorithm is just we go through, we check for mods, and then we check have you seen this mod before. And if we saw the same, like if you have the number that has the same mod by the key, that means there is a subarray that is a multiple of k by definition of mods. So let's do that. So we're going to code this up now. So we're going to just have like mods maybe equals a hash map. And then we are going to have one element in there, remember? So we're going to have a 0, -1. Okay. And now we are just going to go through our nums, and we are going to maintain a total. So, okay, so for num and nums. Oh, we do want the index as well. So we're going to enumerate there. And now what we want to do is we want to say total plus equals v. And then we want to say maybe like mod or something equals total mod by k. Then we want to check if we've seen it before. So if mod in mods. Okay, and then we just do if we want to do the mods mod. So that's going to be the old index, and this is the new index. So we can just do the new index minus the old index is greater or equal to 2, and we can return true here. Okay. Otherwise, so if mod was in there already, we don't really want to update the index to the new one. Remember, we want to keep the old one to maximize the distance. Otherwise, we want to add it in there. So mods mod equals I. And yeah, if we went through this whole array and we never found anything, we can simply return false, right? So I think that's it. Okay, nice. All right, perfect. Okay, so let's think about the time and space here. But yeah, this is definitely like, this question is good, I think, because it helps you get better with your understanding of mods and like, what does it mean if you get the same mod multiple times? And that helps you not get the brute force solution, but instead get the optimal solution. So time. So for time here, we are just going through the array one time. So that's going to be big O of n. Right, this is a linear solution. I don't think we can beat a linear solution for this one. And for space, so technically, worst case scenario, imagine if your k was really big. Yeah, so if your k was really big, and all your numbers gave you different results, then you would be storing n amount of numbers. Like they would all be unique. And yeah, I guess any false solution, all your remainders are going to be unique, right, by definition. Or they're only going to be like one apart. But either way, if you have to be storing every single remainder, and so that's going to be n space. Okay, so that's all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching. Bye.